Hey all, Rob from Atagen here. Just going to do a quick tutorial today on these 3D particle systems using tubes in TouchDesigner. So I'll show you how to make this from scratch. Fair warning, there's a little bit of GLSL involved, but I'll try and keep it as TouchDesigner-y as possible. Alright, let's go. Alright, so first up, we want to have some random for the starting XYZ values. Of course, probably best off starting out with controls. So we've got the particle count, length of the trail, and the speed. Let's quickly fix up the speed there. Alright, so next we'll make sure we change this to a 32-bit float so we get the most precision from location values. We'll change the width to our particle count, so it will generate as many starting positions as we have particles. There we go. And I also might put that on there, so better width. Cool. Okay, so next, we actually want another noise top. And what this is going to be is the animation. So we'll use the initial one, the initial positions, to look up to the noise top. Again, we set it to just a height of 1. Okay, and of course we're going to need these to trail what we do. Oh, of course, 32-bit. Okay, so you can see in the fit top we can make it whatever size we like. Go ahead. The full size of the data, so trail length by the count of particles. Doesn't make sense, it will in a second, so just hang on. I'm going to translate it down, down by 0.5, so it's at the bottom. Then what we want to do is this is going to cycle. I'll just set this up so that it's right away by adding this speed translation. And you'll see very shortly what the purpose of that. Transform that in a feedback loop by 1 divided by the trail amount. And then add it to the original. And of course make the add our feedback loop. And now you can see we've got here a series of, we just turn the speed up a little bit. Down actually. Right, so these positions are sort of streaming from this down backwards through, and we can look at this, the x-axis is time, with the bottom being start, obviously. Alright, so what we've got there, if we just add that so to our starting positions, oops, sorry, we will need a resolution top, that noise, just with a similar treatment. Custom resolution, count by the trail amount, because we want to add these positions to the entire thing, right? Because these noise positions are an offset from these random positions. Alright, so now we've got a bunch of positions. I mean, that's kind of handy for now. Let's go ahead. Name a few. Alright, so we've got some basic positions. And if you want to verify that this is working properly, you can go ahead, open it up, hit D. You should see only small changes throughout that. So that's good enough for us for now. Next, what you want to do, we're going to instance a bunch of spheres to the position, but first, oh no, actually, sorry, that should be fine. Yeah. Pop that out. Now we're going to use manual instancing. And just for the count at the moment. So here's where things get a bit shadery. We're going to put out a Fong shader. And we're going to, material, sorry. We're going to generate the shader from it, assign it. Might as well throw out a render so we can see. Alright. So then we open up the vertex shader of the material. And our next step, of course, is to get our position material. And every time we add a variable to a shader, as you may well know, we're going to declare it. So we've got our position map there. Now, these are actually the heads of the trails, so they're going to be pretty straightforward. All we really need to do here is figure out which one of these positions we need, capture it, and then push it on. So we're going to use texel fetch here instead of the texture function because this gives us pixel perfect, no interpolation, which is what you want for data, obviously. And the instance ID of the geometry is the lookup into the foremost position, obviously with a 0 on the Y of this position map. And something's gone horribly wrong, of course. I'm going to add it to the world space position. And we've got a bunch of floaty spheres. So, not exactly what we're shooting for here, but it's a start. Got some stuff moving where we want it. And we should remember to go back into our noise tops, change the offset. So obviously we want it from +1 to -1. That's how the screen space looks. All right. So we've got some floating spheres, which are going to be the heads of these particles. Now it's time to dive in to the real stuff. And we will be reusing a fair bit of what was in that shader. So we're going to take a tube on the x-axis. This part's important. Make sure you offset it by 0.5. Okay, so that way you can see your tube actually runs from 0 to 1 perfectly on the x-axis, which will be important. There are actually probably better ways to keep track of it than the way I'm going to, but this is by far the most simple and flexible. So put out another Fong shader and the GLSL again. Actually just going to copy that first one because it's got some of what we need. Right, and of course it needs to know what pos map is. And of course it already does in here. So now we need to know, because we're dealing with the trail, first what the ID is, and figure out whereabouts it sits in our position map from that. So the ID, you'll see, is composed of the instance ID as before, so the column, and then the row. So we will get that row by using interpolation across the x-axis, which is why this 0 to 1 was important. All right, so something like this. Also important, your shader will need to know how big the trail is. And you'll see why that is in a minute. And of course, don't forget to declare it within the shader. So what we're going to do to get this interpolated number is just multiply it by the size of the trail minus 1. So it should be pretty obvious why that works. 0 to 1, quantity, scale, multiply, whatever. All right. We also need the next point, and you'll see why in a second. So we can grab that by taking the last one, which is already scaled up, and just clamp it so that when we hit the end, we don't try to index into nothing. And of course, with the next point, we'll need the next ID as well. Apologies in advance for these variable names. Well, somewhat in advance. All right, so we'll grab these two positions from our pos map in the same way. Okay, and we've got the previous and the next. Well, sorry, the current and the next position. And what we don't want to do right now is just add that to world space. All right, so that's pulling all right. And what I'll have to put up here for you now is the article partly on which I base this, which is Shaping Curves with Parametric Equations by Matt Deslorius. All right, the important part here is that he shows you how to take a tube and put it to an arbitrary curve by doing this, solving the Frenet-Serret frame. Don't know exactly what that is, but it works, and it gives you the tangent, binormal, and normal, which if you think about the sort of typical like little XYZ marker, you can think of it like the tangent is like up and so on and so forth. So it's like the three axes that you need for movement. Okay. So to grab the tangent, we need the next position minus the current one, normalized. Of course, they all need to be normalized because they're directions, not actually like places. That makes sense. Grab the binormal by crossing the tangent with the sum. Of the two vectors. And finally grab the normal. He inverts the normal in that. I'm not really sure why he does that. It doesn't need to be done. In fact, sometimes it does weird stuff. So whatever. Anyway, so that gives us that. And right, I have forgotten something marginally important. What we need here first is the angle of the tube so that we can restore that by pushing it out using the TBN matrix. So grab that. Just a simple atan, and make sure, of course, you atan across the YZ axis instead of YX if you're used to that, but you might just do it by default. We also want to take the length of the YZ axis. It's not completely necessary, but it is very useful. And what I'm also going to do here is add a uniform for thickness to the shader. So that will be how thick our tube is. Alright, we've got all our bits and bobs. First we need the offsets from these positions to create the tube derived from the angle. Pretty straightforward stuff. If you've been following so far, I hope that you probably know what we're doing by now. And we are going to multiply that for now just by dist, but later on I will show you how to get the trails using the alpha channel as well with that. And we derive the world space position using the current position that we pulled from our position map. And then, as I said before, it's the binormal. And the normal. You pop it out alongside our offsets. All right. This is doing desirable. No? Ah. Something else important, of course. Your tube, the rows on it, should be the length of your trail. I'm fortunate here now that they already are, but they should be. And what have I messed up? Function name. Yeah. Sorry about that. It's TD instance ID. And of course, we should set world space pos to the world space pos we just calculated. Right, and I've also forgotten to assign the material. All right, so there's something happening. It's a little weird, but it looks like something we might sort of almost be desiring. And if we scale those tubes way, way down, we can see they're sort of doing what we want. So crank the trail right up and we'll see how we go with that. And hey, presto, we've got some wormy sort of things. They're looking good though, right? This is pretty much what we wanted. So next, obviously the normals look a bit wacky and I skipped over that bit. Go in and recalculate the normal. Alright, using the binomial. Make sure we do that. Do our normal function. Alright, and we're looking a lot better there. So these are some pretty comfy tubes. I mean, if you really wanted, you could stop here, but the end of them looks a little bit wacky and, you know, they don't really have quite the flow and momentum that you might want. So I promised you I'd show you a little trick to get those, and here it is. We actually want to start off going all white, max alpha at the bottom, so opposite to how you might have it, and then minimum alpha at the top, and because it's vertical, we add more resolution by going that way on this ramp. Then what we will have is, oh, it's hard to remember. Is it reorder? Yes, it's reorder. All right, so we pull a reorder top in, throw that on, and then take input 2 for the alpha. So now you should be able to see the alpha is just slowly decaying down as it goes. And the useful part of that is we can now scale our offsets down using the position, and hey, we got some pretty nice tails. Additionally, we can actually sort of pull some reasonably nice coloring tricks by using that as a lookup into a color. So I'll do something easy, just don't have to think about it too hard. All right, and that's not looking too bad. Of course, we would need to go ahead to our other shader and color there too to match. You can of course also use that pos_w attribute as a lookup into something to color, which is a nice little trick, but I won't show it right now. All right, so there we go with the basics. And I mean, we can crank this right up. It's all on the GPU, so if it runs, it pretty much runs. When it crashes to a halt, it really crashes to a halt. But you can definitely get pretty good stuff. This will take a minute because the trails have to initialize their positions, and plus it's not going very fast. Anyway, so that is the basic setup of it. And given that we've got all our things set up there, we can just sort of freely mess around with whatever variables we like, although of course we should probably add something to make the spheres be the right size so that you get that kind of seamless tubey look. All right, well, that's the basics of it, and I hope you all enjoyed it.